Let us see the signum function. Now here for x not equal to 0 it is this value, and for x equal to 0 it is 0. So we have to see that where is the definition breaking at 0. For x not equal to 0 it is this value, for x equal to 0 it is this value. So it is, the definition is breaking at x equal to 0. If you write signum function, we can write it like this: for x greater than 0 it is 1, for x less than 0 it is -1, and x equal to 0 it is 0. We draw the function. For all the values less than 0 it is -1, and for all the values greater than 0 it is 1, and at 0 it is 0. So we have to, in this kind of function, we always have to check the continuity at the point where it is breaking. That means here the definition is breaking at x equal to 0. So in order to check the continuity of a function, we have to check at the point x equal to 0. Then we have to check the continuity at 0, a value slightly less than 0, that is, we call it the left hand function, left hand limit, and at a point slightly greater than 0. For these 3 points, if the values are equal, if the limit gives us equal value, then this function will be continuous function. Now we see that at x equal to 0 the function is 0. At x slightly less than 0 the function is -1. When we say x slightly less than 0, it may be value like minus 0.0001. So a slightly less than value, less than 0 may be point here. So it is, for this it is 0, for this it is -1, and for this slightly greater than 0 is 1. So all these 3 values are not the same, different. So this function is not a continuous function. So in this case f of 0 is 0, limit of x tends to 0 minus fx is, that is, when 0 is, the value of x is slightly less than 0, then it is -1. Limit of x tends to 0 plus, that is, when the value of x is slightly greater than 0, it is 1. So these 3 values does not match. This is a discontinuous function. This is how we prove using the definition. But clearly from the graph also we can see that this is a discontinuous function at the point x equal to 0. So the fx is discontinuous at, this signum function is discontinuous at x equal to 0. For other points, here for these points it is continuous. Here also for these points it is continuous. Only at x equal to 0 it is discontinuous. Let us see another very important function, sine function. We have already seen the graph also like this. This is the graph. It starts, if it starts from 0 here, it goes like this, 1 at pi, and then and so on at pi by 2, sorry. So at pi by 2 sine gives us 1, and it goes on like this. It is a continuous graph. So we have to remember that sine function is always continuous. Now we have cosine function. Cosine function also, it is a continuous graph or continuous function. Here, this we have to always keep in mind. Now graph of tangent. Now the graph of a tangent is always like this. If it starts from 0, it goes like this, and at pi by 2, it is undefined. That means the function is not defined at the point pi by 2. So this function is discontinuous at pi by 2. Similarly, if we start again from a point slightly greater than pi by 2, then we have points like here. It goes on and goes on and goes on. It keeps increasing. And as it reaches 3 pi by 2, again it becomes discontinuous. At 3 pi by 2, it is again not defined. So in this way, for tan function, it is not defined. It is discontinuous at points pi by 2, 3 pi by 2, Again we have 5 pi by 2 and so on. For all the odd multiples of pi by 2, tan function is a discontinuous function. These three are very important. We always have to keep in mind. Now this is the algebra of continuous function. So if f and g be continuous functions, then the sum of the function is continuous, and if we minus f minus g, then also it is continuous. If we multiply c is any number, with f, it is always continuous. Again the multiplication is also continuous, and the division f by g is continuous at those points where gx is not equal to 0. So for all the points where g is not equal to 0, this function is continuous. So we can take example, say sin x function. We have just seen that sin x function and cos x function are continuous. Say this is fx gx. So if you write sin x plus cos x, it will be continuous from the first one. And again if you write sin x minus cos x, this is also continuous. This is for all x in the real number. For all real number, these are continuous. Now if you multiply sin with a scalar, then also it is continuous for all x belongs to R. And then if we multiply sin x into cos x, these two are continuous function. Even if we take the multiplication of this continuous function, it is continuous. Now the last one, sin x divided by cos x. So this is continuous function provided cos x is not equal to 0. So for all the values of x where cos x is not equal to 0, this function is continuous. Now if we see cos x is 0 when x is pi by 2, when x is 3 pi by 2, and so on. So cos x, in this case sin x by cos x will be discontinuous at points x equal to pi by 2, 3 pi by 2, and so on. Or this, what is sin x by cos x? It is tan x. We have seen that tan x is discontinuous at these points. So this is a very important concept we have to always remember. Next, we have to remember that every polynomial function is continuous. This is very, very important. And also every rational function is continuous. All this we have to keep in mind.